Hello everyone. I am Shubham Tiwari from MIT Academy of Engineering, Alandi, Pune. In this video, I am going to present on the topic permeability. My PRN number is 202202030032. The points which I am going to cover in this presentation are definition of permeability, Darcy's law, factors affecting permeability, determination of coefficient of permeability by lab method, and limitations of lab testing. So let's get right into it. Permeability. Permeability is defined as a capacity of soil to allow water pass through it, that is, quantity of flow for a unit of soil surface under a pressure of 1 unit hydraulic gradient. The permeability study is required for designing of earthen dams and for determination of the quantity of seepage under hydraulic structures before and during the construction of the foundation. Soil are permeable due to existence of interconnected voids through which water flow from points to of high energy and point to the low energy. A soil is highly pervious, then water can flow through it easily. For example, gravels. And if a soil is impervious, the permeability is very low and water cannot easily flow through it. The example is clay. Here we can see that rocks are impermeable. Darcy's law. Darcy states that for a laminar flow through a saturated soil mass, the discharge per unit time is proportional to the hydraulic gradient. Here are some assumptions. He assumed that the soil is to be saturated and the flow through water should be laminar. He also assumed that the flow will be continuous and steady, and the time when the test is being performed, the temperature will be 27 degrees Celsius. And last point is that the soil mass of total cross-section area is to be considered. The Darcy's law is only valid when the flow is through laminar. For a laminar flow, maximum particle size permissible is 0.50 mm. This law is valid for clay, silt, and in fine sands. In coarse sand, flow may be turbulent, so it is avoided. The relation between the velocity and hydraulic gradient is assumed to be linear here. And last point is the extremely fine-grained soil such as colloidal clay whose velocity is very slow, such type of clay is not considered uh, or it is not valid for Darcy's law. Moving further, we have factors affecting the permeability of soil. The very first point comes here is particle shape and size. The permeability varies approximately as the square of grain size. It depends on the effective diameter of the grain size D10. Permeability is inversely proportional to the specific surface. For example, as angular soil have more specific surface area compared to the round soil, therefore the soil with angular particle is less permeable than soil of round particles. The next point comes here is void ratio. Increase in the void ratio, increase in the area available for flow, hence permeability increases for critical conditions. The next point comes here is degree of saturation. The permeability of partially saturated soil is less than that of fully saturated soil. As we can see in this two images, there is a little bit air void found in this soil samples. The next point here is entrapped air and organic impurities. The organic impurities and entrapped air obstruct the flow of coefficient of permeability is reduced due to this presence. And the last point is adsorbed water. Adsorbed water means a thin microscopic film of water surrounding the individual soil grain. This water is not free to move and hence reduce the effective pore space and thus decrease the coefficient of permeability. After having a look over the factors affecting the coefficient of permeability, let us have a look over determination of coefficient of permeability. Before starting with the point, let us know what is coefficient of permeability. Coefficient of permeability is defined as the average velocity of flow that will occur through the total cross-section area of a soil mass under the unit hydraulic gradient. Today we will be having a look over constant head test on permeability. So constant head test of permeability is used to measure the rate of the flow of water through the soil. This test is primarily used for coarse-grained soils. In this test, water is forced by a known constant pressure through a soil specimen of known dimension and the rate of flow is determined. It is suitably used for sand and gravel for testing the drainage capacity. This is the apparatus of the constant head method. In this type of laboratory setup, the water is supplied at the inlet in the edge is adjusted in way such that the difference of head between the inlet and the outlet remains constant during the test period. After a constant flow is established, water is collected in the graduated flask for a known duration. These are the this is the height, length, and time required, and with all these parameters, we get the formula for the coefficient of permeability by constant head method as QL upon AHT, where Q is the volume of water collected, A is the area of cross section of the soil specimen, and T is the duration of time of water collection, and H is the height difference. Limitations of lab testing. The very first limitation of lab testing is that it is difficult to replicate the in situ soil condition. The structure of in situ soil may be disturbed because of sampling and test preparation. Small size of laboratory samples lead to affect a boundary condition, as variable consolidation pressure and void ratio from the top and bottom of the specimen varies as that in the situ condition. And also there is no control over degree of saturation as we can see in the natural condition. Hope the idea is very much clear about the basic definition of permeability and the method to find the coefficient of permeability. That's it. That is it from my end. Thank you everyone. Happy learning.